Good morning. Nature is healing because I'm finally wearing makeup and a cute little fit again. It's been a minute. It's been a minute. But so in my last video at the end, I said that I was going to show everything to my supervisor, and I did have a meeting with my supervisor 2 days ago and it went well and he gave me good advice about moving forward, and I wanted to talk about it because it's going to shift the next part of the project. So here we are in my random unnamed document that I need to name and put where it needs to be. But I showed my supervisor like all this, and he was like, cool. He had questions that I had. For example, why does it only show one line? I was like, I really don't know. I need to fix that. But obviously it worked pretty much okay, except for there's one where it like the original pattern gets messed up, but we need to fix it. But it's like, okay, so it kind of essentially works. He told me that I should explore more now. Um, like I don't have to just do this. What I could do is like test like another feature of acetylcholine. And then he said like he was giving me like options. He was like, you can explore more. You can like walk through in your paper like the different things you explored. And then if you want, you can do one where they're all like kind of squished together, like put what like all of them are all the effects kind of at once. I really want to do that because I really want to look at pattern separation because I feel like that also has some like is going to have some ramifications as to like how dissociation is. I don't know how to put it because especially because memories get over encoded in trauma. And I just like I have some things I want to talk about in my conclusion that have to do with pattern separation that I think are important. So I think I am going to talk about I'm going to try to that's probably going to be like my next aim, and also to fix my old one up a little bit more and everything. I just asked a lot of questions about the technical stuff. I was like, am I using the right language for this? Is it okay to use numpy or is there something that would be better? And he said that's fine. So yeah. And then he told me how to start getting numbers, like because I have to like basically have like results to show like, okay, yes, it is more than this. And he told me how to calculate the difference and plot some graphs and all these different things. And he said do it 100 times or so and then see how good, like generate averages from that and make graphs. I'm not going to worry about that yet just because I'm very intimidated about writing my results section, to be honest, because like I've mentioned quite a few times, math scares me. And I'm planning, like I already made like a whole plan to go back and practice and learn math up again. Like, practice my really root math skills and like work up so that math is doesn't intimidate me anymore. But I thought that I was a humanities person growing up, and I am, but it's like, I was like I had geared my whole personality and my whole like relationship to school around that to the degree where I was like, math doesn't matter. I'll just get my grades. Do I understand it well? It doesn't really matter. And we had some iffy moments in math, like in this is insane. Okay, so middle school I was struggling with my math teacher who just didn't like me because of my ADHD tendencies, so I got a D. And then in high school, actually, I had such bad luck because my school, I went to like a prep school for inner city kids, essentially. It was meant to be for low income students, students of color that live like in the inner city. It's actually pretty cool. It's like one of the first, I think the first school in the country with that setup. So it's pretty interesting. But that's the school that I went to. And we were great and we had like great teachers, everything. Only problem is we were just a normal public school, so actually at the end of the day, so we still didn't have like, the best funding in the world at all. We had more APs than the average high school in my like public high school in my city, and to be fair, a lot of the public high schools in my city are crazy rundown and just not the best. Unfortunately, that's what public schools are working with because idiot billionaires and politicians keep cutting education funding. So that's how it is. But basically, we just didn't always have the best funding. The only thing is our alumni base is really strong, and like people really like. I feel this way too. Like I'm excited to go back and like be active in like my high school community, because I believe in its mission and it's a good mission, and they try to get everybody into college, which is a really big deal for like for the population that of my school. It's like majority black, a lot of Hispanic kids and everything. So it's like a really big deal. Okay. Anyways, but our funding just wasn't the best. And with the years that I was there, we had like a blip where we struggled. Like my first year math teacher, she got like fired midway through the year. So we had a sub for the rest of the year. So we already had really, really like struggling SAT scores or standardized test scores my freshman year. Then from that point on, we had yeah, the rest of the years they were just like tough because everybody was behind. There was one year that almost everybody, like a lot of kids failed our standardized tests because I'm not gonna say everything, but we just had complications with the math department. And yeah, so it was a lot of like, even though our teacher would like pass us, did we actually know what we were doing? Like, no. And it would be very obvious when the SAT time came, or like, for example, I took AP calculus, and none of us were actually, I mean, I'm not gonna go into it, but we had some struggle years there, and really only one person I think even passed my the AP calculus test. Nobody else passed, but I still got A's. I don't know if that demonstrates anything, but anyway, so we just really had struggle years in math, and then we even almost lost our accreditation while I was there for math for the like over the math thing, which is insane because we're one of the best schools in the city for public schools for like the pop, you know what I'm saying? So it was like a big thing. So I just kind of had like a struggle time with math. I don't think I ever got like my foundation in that well with math, and I'm trying to like catch up better and stuff, but I just my confidence in math isn't the best. So I'm kind of scared for this part, but obviously I've learned all of this. I can I can figure it out. So we'll be fine, but it kind of scares me. It's really not that hard. I mean, it's like calculate the difference between, it's like, it's not that hard stuff, but it's just like, I'm scared because I'm like, oh my gosh, math. I was like, when I finished, I was like, I can't wait to never take math again. I was like, I'm done with math. I'm going to college. I'm a humanities girl now. I never have to take it. And it's like, I never like, because of that, I just didn't put the effort in. So, anyways, yeah. And then think about how to get numbers. Okay, so this is all we talked about. So, do I think it's going to impact capacity? Okay, so this was my supervisor. This is like all him, all his idea, kind of like he was saying something that he'd be really interested to know and like that he thinks would be a good thing to see is so I need, this is one of my next things on like my learning to-do list, is that basically, so there's like a capacity. I was just like gleaning on this subject in my last video by accident because Claude Code mentioned it, and I was like, oh wait, I kind of need to learn that. But there's like a capacity out like for the numbers at which like uh once it reaches that point, it's like it's kind of distorting things essentially. And basically it's almost like the system starts to be like, oh, system overload, there's like a lot happening, and it just starts to kind of disrupt it. So he drew this picture here. He was saying that I should try to see like what if the problems are worse at maximum capacity, and I should do like a little graph thing where it's like at each point, it's like run each point like 100 times or whatever, and see if like he thinks that probably like it would be worse. Yes, when acetylcholine is up. I don't know. I have to like wrap my head around that, but he was the one who was like, it would be a really good like graph to have. I believe him. He knows what he's talking about much more than I do. So I'm gonna try to learn that and do that. Noise levels. He thinks that capacity with acetylcholine being high, capacity will collapse before you get to the theoretical capacity. So I need to learn all of that essentially. I don't know what I'm gonna do in this video yet. I'm not even gonna start yet. I'm gonna go out and like have my day. I've been trying to like spend my weekends actually doing things you're supposed to do on your weekend, because for the last year, I basically like for the last 3 years, I basically just work like 6, 7 days a week. Like honestly, like I don't ever, I'm not like weekends and then weekdays. And I've been trying to fix that so I get less burnt out. But I just wanted to like mentally unload all this. I was like, okay, this is basically everything that's going on. So I need to like, the next things to do will probably be like, there's still some little issues on my code. that for like my original one that I want to fix. Like for example, issues with like how the patterns are set up and stuff. And I'm like, what's going on here? But beyond that point, I think like I don't know if I should. I think like the next thing I want to do is get a result for pattern separation and see if I can even find a way to implement pattern separation in my Hopfield network. How to do that, I don't know. But I also could spend some time learning, for example, this capacity thing. Um, I don't know. We'll see where we go from here. Actually, I have really no clue, but yeah, basically that's how it went with my supervisor. And yeah, he was like, we can do a check-in soon because he said I'm actually starting to get results. And I was like, oh, because like I don't know, that's crazy. Like it is kind of I'm starting to like get to that point where I'm starting to have like a semblance of results, except I want to troubleshoot and everything. But yeah, so that's pretty cool. Hello, happy Easter. It's the 5th of April and it's Sunday. But I was also reading this book today called Make Your Own Neural Network by Tariq Rashid. It's really good. It's like it's really geared towards beginners and he's very good at like communicating in a non-intimidating way. He's very it's like a very informal tone of a book and I don't know if you can tell, but it kind of looks like he wrote it on like Word. Let me see if I can get light on it. Okay. You can tell that he kind of like he just was probably he's probably like a professor or something like that and I think he just basically like it's not even the most typical font you see and he has like I don't know if it was on Word, but it's like it doesn't look like a super duper formal, but like it's excellent. Like it's very very good. It's great to read and it's easy to understand and it has good pictures. And he literally walks through like the whole code and he just walks you from beginning to end of like literally how to make a neural network. Like you can see he like it's a good book. I recommend it for beginners if you're a beginner like me. My supervisor advised me to basically he advised me to do certain stuff. He started telling me how to basically unpack the results or like find results, measure the results, measure the output, and he explained to me how to he was telling me to run it like 100 times and just all this different stuff, make it into like images. And he was kind of going into that at the end of the book in like but with different themes. And that was really useful to me. I'm trying to show what I read today. I made it actually, I read all this at a Vietnamese restaurant and I made a little list of like what I'm going to implement and I'm going to see if it's feasible. This is page 158, testing the network. And he talks about how to create loops. So he's making one. I think what he's doing, it's not his that he makes in this like example is not an actual. I don't think it's a Hopfield network because it's got like hidden layers and stuff. So I think it's like it's definitely. I don't think it's a hidden. It's not a Hopfield network. But that's gonna look at handwriting. It's like a standard one to teach. It's like it's looking at like handwriting and it's analyzing what number that handwriting is. I read this exact example in Surfing Uncertainty. Basically, he was showing how to create a loop to go through all the test records, how to create a scorecard that tests how well the network performs. I'll show you. It's probably, I don't know if it's backwards, but he just makes like a box and then at the end, networks answer matches correct answer, add 1 to scorecard. If the network's answer does not match the correct answer, add 0 to scorecard, which is probably not exactly what I'm going to do, but it just gave me that inspiration. So he talked about how to do that. And then this is what my supervisor was kind of referencing on how to actually get a number for the performance. So he was showing how to calculate the performance score, the fraction of correct answers, to basically work out the fraction of correct answers. And then it spits out like a percentage. Again, not exactly what I'm going to do, but it inspired me because I was like, okay, I'm not going to do I don't have to do this manually. I can basically get a code, like make a code to do that. And then he compared it against industry benchmarks on like a website. So again, all this is just giving me inspiration. And then he talks about how to make improvements. So tweaking the learning rate, that was one thing he did. And then he made like a whole graph out of it where he showed like what the peak learning rate was. And that was like good example. He showed how to do multiple runs and see like basically like the peak amount of like learning. And then he talked about some stuff that I think will be just generally important for me, or like good info. So what he was saying for this one, for example, was I would have expected much more variation in the results because we've not done many experiments at each data point to reduce the effect of expected variations from what is essentially a random process. That's why I've left that odd point for 6 epochs in to remind us that neural network learning is a random process at heart and sometimes cannot work so well and sometimes work really badly. I don't know if this is the exact place. It says to do it properly, you would have to do this experiment many times for each combination of learning rates and epochs to minimize the effect of randomness that is inherent in gradient descent. I'm assuming that some variation of that will be relevant for me, where it's like I should run things a bunch of times knowing that like certain things can go off. I think, I don't know. That's what they're talking about here. And my supervisor did say that I should run it like 100 times. And then at each point, like this one, at each point have like a little graph with like a bar. And that was what the picture in the last clip was, where he was saying that I should do it for like learning capacity. So this book has been really helpful. I haven't been reading it from beginning to end. I started in the beginning and I've been reading it like at night, but I've been slowly writing like all my learning tips, self-learning tips, and like I want to write this as a book one day. But it's like I was writing it more at work today. I had work in the morning, but I was like, I think a mistake that a lot of people make is that they feel like they have to read, like their school teaches us to be very, a lot of people feel like they have to read everything from beginning to end and understand every single word, and they don't like to kind of jump around and stuff. And so then like they get overloaded with the massive task of learning. And something that I've learned from my learning journey with this is that it's actually good to skip around and to take what you need from the material. And I am going to read this full book, but I was like, I think in the past, before I started this whole entire experience, I would think like, you have to read every page word by word and you have to understand everything. If not, this is not a thing you can do. Where I'm like, okay, I don't fully understand this, but we're going to come back to it. And like, I trust that over time I'll understand this well. I have been actually processing a lot of different things about this project, about my neural network, about the next part. So the last few days I've been processing like quite a bit, just thinking about how I'm going forward. I've been thinking like I'm going to try to open terminal now. Wait, while Jupyter Lab opens, these are all of my like troubleshooting things that I've done so far. There's still fixes I want to make, but I'm gonna write down here like, okay, these are all the notes from my supervisor meeting. I have things I want to learn this week. So signal to noise, is it signal to noise ratio, or is it noise to signal ratio? I don't remember. It's one of those. I have other things I need to learn. I'm gonna learn more about that theoretical capacity situation. I was actually reading in this book. It was like a slightly different thing, but it was like similar still. It was talking about learning capacity here, but it was talking about it like it was referring to amount of nodes in the network. It was talking about hidden nodes, but it said if we had too few hidden nodes, say 3, you can imagine there's no way there's enough space to learn whatever a network learns to somehow turn all the inputs into the correct outputs. It would be like asking a car with 5 seats to carry 10 people. You just can't fit that much stuff inside. Computer scientists call this kind of limit a learning capacity. You can't learn more than the learning capacity, but you can change the vehicle or the network shape to increase the capacity. So that's basically like that's like a little mini summary, but from like a different context. What's crazy is like I showed my supervisor my thing, and he was just looking at it. He was like he just looked at the numbers and was like, yeah, so this can probably tolerate like blank and blank amount of patterns, right? And I was like, yeah, what the heck? And I'm like, how I'm awed by people who are just experts in their stuff. Cause I'm like, I'm sure like at some point it's like, oh, that's just easy stuff. But to me, I'm like, how did you even know that? Like you just looked at it and like 2 seconds later you were like, yeah, so this is probably like this amount, this amount. But I think I'll learn that myself over time. But to me it's still like magic. I actually can't wait till I actually know what I'm doing more. And I look back and I'm like, that's like doing 1 + 1 is 2. But to me now I'm like, what? How did you know that? But yeah, so anyways, so he told me, he was like, so it can only probably store like 1 to 2 patterns, right? I was like, yes. But right now it has like 4. And for some reason it's saying patterns. There's like this is like a whole mess right here. So I need to figure this out. I don't know. We're just gonna keep it at 5 for now. I need to fix it. I'm surprised Claude Code didn't mention a word about that. Like it wasn't concerned. I think it was busy looking at other stuff. So this is my one that I was working on that now does have acetylcholine in it. And this worked. I will say though, I'm not 100% satisfied with my solution. And maybe it's right, but I don't know. I don't know. Actually, maybe it's fine, but I've been still thinking around a little bit because it just feels like it's not. I don't know. I don't know if it's like satisfactory, but maybe it is fine. I just thought like maybe if I played around with the temperature, I don't know if that's actually even accurate. I just thought like I just can't. I don't know. We'll see. Maybe I'll like. I think maybe by the end, if it's meant to be more something than this, or like more fine tuned, like I'll figure it out. If not, whatever. This is what I was thinking about today. This is now my weights function. Claude took my little for loop. Claude took my for loop. So that's really sad. I miss it. However, I was thinking, so okay, so my supervisor told me to keep playing it around with this and like see if I want to see like some more elements of acetylcholine and how it works. And I really want to look at pattern separation, like I said, because I have conclusions that I want to make based on pattern separation of like, okay, these might be other ways that it's impacting like this and that. So I really want to include it. Pattern separation, basically what like this is like the simple, very simple like explanation that of like not that sophisticated, but there's a part of your brain called what's it called, dentate gyrus or something like that. Yes, I think that's how you pronounce it, dentate gyrus. Basically, like when acetylcholine is up and you're learning, it like it's like it takes all of the things that you're learning and makes them like really like fine tuned of like I don't know how to put it like it's taking the information and making it all like very very like separate and distinct, if that makes sense. I don't know if that's how you put it really, but then when it's like lower, it's like things are a little bit more bundled up or jumbled up. I don't know. Maybe that's why you feel more focused. But it's like this is like these are like very distinct qualities. Like it just gets more like this is like here and now and like here's the elements versus like if you're just kind of alert, like it's kind of like, huh, what does this mean? Like, it's like things are just they're not as like you're not as tuned in and like things are just a little bit more like doesn't really matter if you see like every little last detail. I don't know if that's really the best way to put it. I don't know how to put it into words, which means that means I should do more like thinking. But that's the gist of it. And basically, yeah, so when acetylcholine is up, when during encoding, it like separates the patterns out more. And this is what I was thinking about today is that obviously like I feel like what I'm seeing about a Hopfield network is that this is like its encoding phase. And this is like the recall phase. And basically for the recall phase, it's almost as if acetylcholine is way down. So this is like its sharp wave ripples. This is what I was looking at sharp wave ripples. These are like the sharp wave ripples. And then this right here is like the acetylcholine is up encoding phase. But in the most basic one, it basically would be assuming that everything is like the most perfect version of it. So it's like this is like if you have like perfect arousal levels that are just optimal, and this is like if you had the most perfect sharp wave ripples. I mean, not now that I included acetylcholine, but it's kind of like perfect encoding and perfect recall in theory without any kind of like chemical difference. So it's funny because here it's like as acetylcholine is going up, it's making you less able to recall. But actually, like acetylcholine, when it's up, it's supposed to be like making your memories more sparsely coded. I think if that's the best way to put it. I don't know if I'm mixing up terminology here, but basically it should be like this is like a very distinct episode. Actually, I'm actually excited to write my cognitive psychology paper. Because now it's basically just gonna be me like info dumping, but it's how reliable is long-term memory. And I'm actually really excited to write it because I already have so much in my own like archive of like research papers that I've read. But the thing that's really interesting that I read in one paper is that actually when arousal, like there's this thing called the Yerkes-Dodson curve or something. And the idea is that when arousal is really, really like when arousal is really low, like you're just kind of like not that tuned in. Your memories are like not they don't stick around in your long-term memory that much, and they very easily fade away. You don't have like the best recall for them because it's like, it's like if I were to ask you like what did you think about like I don't know, like tell me how you felt when you were putting your shoes on yesterday. You're like, I don't know, I don't remember because why would I care? Like that has no importance to me and I was not like paying attention to that, right? But if I asked you like tell me how you felt when you were watching your absolute favorite TV show that you're obsessed with yesterday. Like you could probably tell me. So arousal actually impacts like so if your arousal is low, your memory's not that great. If arousal was like really, really high, which is like kind of what I'm trying to test, also it can impact your ability to create good memories because it's like things start kind of breaking down and you don't get it kind of creates like your memory binding isn't as good. That's what the paper was about. Like it kind of like distorts the way you bind your memories. But if the arousal is like medium level, that's like optimal. So like, something that was like, oh, I was really tuned into that. It was really enjoyable, but I wasn't like traumatized by it. You're gonna like probably remember that for a very long time. Like, I don't know, your first kiss or something, or like the time you went to prom. Like those are like, okay, you're probably going to remember that for a very long time compared to like, tell me about the second Tuesday of your math class in middle school. Like you don't know anything. So anyways, why was I saying all this in the first place? The reason I was saying all this in the first place is because actually, so acetylcholine being up isn't even a bad thing. Like you would want acetylcholine to be up when you're encoding memories. It's just that if it's up in like a stress condition, it's not this is a thing that actually is like kind of like okay, if it's up, it's not even necessarily it being high that may it's is like a bad thing, but it's like it being high in like stress conditions. So I do need to go into that in my paper because from what I saw, it wasn't necessarily that like it wasn't always correlated with like numbers of like, oh, if it reaches X amount, it's like worse or better. In the in the rat papers that I read where the rats were having like a stress condition, in one that they were stressed out for a minute and they did enter a freeze state, so they did have a stressful situation. It was up really high, but they were only in it for like a really short time and it wasn't really inescapable, so they actually froze, but they weren't like they didn't see necessarily the same impact as my other papers with inescapable stress in rats, where the acetylcholine wasn't even up as high as those rats were, but they were like trapped, and so the acetylcholine was up for a longer time compared to maybe I need to implement that. There's actually a lot to think about at this piece because acetylcholine being up chronically is already like that's not good. Like if it's up when you should be encoding, that's like, just like obviously a bad thing. But there's a little bit more nuance when it comes to because actually acetylcholine being up, I'm like it's not all that would be happening is like the patterns would be like very distinct from each other. Where I'm like that's actually a good thing. That's not a bad thing. The bad thing is if it's up like in a like chronically, like inescapably is like the bad thing, which will be shown by this part. This part will definitely demonstrate that. So, but it doesn't hurt still to show like that difference anyway. So I'm obviously still going to try to include that, but these are just like interesting nuances of acetylcholine as well. But actually, what's the papers, these same papers that I read on rats in inescapable stress, they actually looked at the dentate gyros as well. So I'm going to try to find them. I've been trying to like think about how I'm going to implement that myself. You see, I think this is one of the ones that I read on acetylcholine, but I might be wrong. This is chronic stress though, and I'm not looking at, there's like a lot of difference. There's like a lot of nuances to this part because there's like, you know, a second of stress. There's inescapable stress, which is more traumatic for the rats. And there's also like chronic stress, which I'm not looking at, though it would be very interesting in the like one day. I swear I saw one on acetylcholine. Anyways, I might do some reading because that's actually the place that's being, the acetylcholine being up is impacting the dentate gyros, which is impacting, like, that's where the patterns are getting separated. So then, like, by the time it reaches the hippocampus, like, there's like a different kind of energy going on with how the memories come in. What I could try to do is that I could like, these are the different patterns. There's like a noisy pattern. I could try to like, okay, these are like just different initial thoughts. I could try to do like an inescapable stress pattern that is more representative of how it's coming through like the dentate gyros. I don't know. That's one thing I could do. I don't know if that's really like the best way to put it, but that's like one place that I could put it. So it could already just be kind of like learning a trauma memory instead of learning like a normal memory. That could be like one good way to do it. The thing that actually I could see here as well, these are like all of it culminating now, is that actually high like inescapable stress, it actually impacts the way like long-term potentiation is formed in the CA1. So it actually makes less LTP or something. So I could just have like one that's just an inescapable stress condition as well. So my supervisor was saying I could run like a lot of different experiments. So I could just basically implement, like I could do one that's okay, straight up what's happening is like, so I could do like just acetylcholine, like high, and then you get the pattern separation. And then I could just do like a normal consolidation window with like normal recall. So that would mean that in like the weight section, the acetylcholine like would dictate the pattern separation. So you could see acetylcholine like low, you could see it high, and you could see like, okay, when the acetylcholine is low, like it remembers, but like the memory is kind of like, I don't know. Actually, I have no idea how I'm gonna do that, but you could see that it's like it's not that crisp. Memory is not that crisp. I actually have no idea how to implement that yet. We're gonna have to do thinking on that. And then you could say like, but it does consolidate, and then like the memory can be consistently recalled the same way, like, or accurately, essentially. So it's like, yeah, it's not like that crisp of a memory at like this amount, but it's like it does remember it fine every time. And then you could see here, it's like, okay, this is like super duper like crisp memory and it remembers it well every time. So you could do that. And then you could see one where it's like, okay, acetylcholine is high and acetylcholine is up during the recall phase. So then you can see like, okay, just basically the same thing. It's like, oh, like not a crisp memory and not well remembered. And you could see like, or like it is a very crisp memory, but you can't remember it. The reason that this would actually be like relevant in like a trauma phase is that actually the problem with traumatic memories. And this is the thing that people critique. And I really want to talk about this. This is like a criticism in people that are like, well, what about like is dissociative amnesia real? They're like, why would it be both over encoded and forgotten? And then you can see, well, like the acetylcholine was up, so it did make like a really crisp, well encoded memory, but you just couldn't remember it because the acetylcholine stayed up. So that was actually one of the big things that I wanted to like angle. So that explains like why that phenomenon exists. And then I could do like an inescapable stress condition of some kind if I wanted to get like real fancy with it. And I could show like a little bit more. I could show like, okay, LTP is impacted, and maybe I will change some kind of pattern. Like you get some kind of like really messed up pattern. I don't know. And so then you see everything that's already like built in. You see the whole acetylcholine like story, and you basically see like, okay, so like really like a bunch of stuff like went off. So I think these could be like different things that I could do. And I think that if I just do pattern separation and that recurrence, like I just wanted to answer this question. This was like my number one question that I wanted answered by my research is like, why would it be both over encoded and forgotten? And that's why is because like the pattern separation is like super, like, you know, the patterns are very separated, yes, but also they're forgotten. And then when you come here, then you really see like the whole picture, because you see like, okay, CA1, like the long-term potentiation was like not as much because of the stress conditions, but what was remembered was like very separated, but the acetylcholine was up, so you could not remember it. This is kind of like a range here. So these are probably the different things that like I would be interested to show, I think. And I think like between all of that, I kind of got like, I kind of have my picture. And then lastly, we would show as well what my supervisor suggested that I think is really good, and talk about that capacity situation of like, I need to do more reading to figure out like where, like which of these conditions should I use to answer that question. Maybe, yeah, I think this is like a pretty solid plan, actually. So I'm pretty happy with that. It's like a good little list here. And it kind of just fits everything that I was gonna figure out anyways. This is like, I don't know. Yeah, I think everything is good. I need to figure out this one. But yeah. And then basically to like understand how, like if this is all accurate, this is what I was thinking is like, I need to include lines of code that are not there yet. And one of those is like in my book, it made a scorecard. So you could see like how accurate was like the network in each piece. And then you know what I was thinking though is yeah. And then you want the average of that. What I was thinking though as well is, this is a question. Can I just make it, and I think I saw this in the book in a certain, like to a certain degree, can I make it like run many times, like automatically through a line in the code and average? And I think that I actually did this myself during the summertime when I ran my really, really messed up but useful like code, like ChatGPT code. And I had it like, I don't remember what I had it do, but I think, oh, it's because I made it like run like 12 run it like 12 times as if it were 12 rats. That took forever. Like it took a really long time, and you kind of had to just sit around and wait. But I don't know if it can do it 100 times very easily. But can I do it like, maybe I can make it run 10 times and do that 10 times? Like maybe like 10 times automatically, get those numbers and then average it out, so I'm not sitting for like 6 hours, because 100 is like way too much. So yeah, these are things that I need to implement. See, that actually goes to show how it was actually useful to do that stuff over last summer, because it's like I remember doing this. And yeah, this is all new stuff that I'm probably gonna figure out this week. I want to read my papers again and just go back over. And actually, I think writing my cognitive psychology paper will be good, like a good refresh, because I'm actually gonna go back. Like this was what I was thinking over the summer when I was or like when I was starting my project. I was like, oh, it's gonna be so good to make this list because I already have so many papers for my papers. Like I don't have to do as much research. And it really has not come in handy up until literally right now, but it's good because this paper is worth 100% of my grade. So yeah, but it'll be a good paper, I think, because I'm going to talk about like it was like how reliable is long-term memory. Like, bro, I got you. I will talk about neuromodulators. I'll talk about arousal. I just have a lot of good information on that actually, so that makes me happy. But I might go back over my papers as well and just remind myself what I learned about the dentate gyrus and pattern separation and acetylcholine and see. Yeah, I feel like now I'm on a roll, actually. Like, I feel pretty good. And the other thing that I need to learn this week is about like noise to signal ratio. I put this in my thing. I have to learn about capacity and I have to learn about signal to noise ratio. Yeah, this is my reward for doing this work. Yeah, those are things that I hope to learn this week, starting with these two. Yeah, anyways, now I just feel like I just feel like I'm on a roll and like I've got like good information. I got my neural network book that I'm gonna keep reading. I still want to think more about the acetylcholine that I put in like my second, like how do I put it? My like this part because I don't know, like it works. I just want to double check and like make sure I feel good about it. It just feels like it's almost like it feels like a solution that's like on top versus inside. But I might be wrong on that. I just feel like ChatGPT kind of like didn't like it last week. It made it and then it was like, no, this is just like a this and this and that. So I was like, wait, maybe I'm not like maybe this isn't the way, but it just felt logical. I don't know. I don't know. I'm just gonna check on it more and see, but we'll see. I don't know. Maybe it's fine. All right. I'm actually really pissed off because I was finishing editing my video. Teams does this really annoying thing where it's like if I have too many videos in my OneDrive, it like just takes all the noise out of my videos. But I didn't have that many videos, so it basically just stripped the noise of my video of me having such an important moment in my project. So I'm just gonna have to show it now what I did and what I found, and that's fine because it was getting long anyways. All right, so I made a few little changes here. I had a really annoying moment where like, okay, so I'm not including these clips because I just thought they were boring, but I basically tried to implement energy and stuff because I was reading about energy and then I was reading about signal to noise ratio. It's SNR, signal to noise ratio. And I was like, I was curious. I was like, I was trying to learn about energy and I was like, I want to see like I want to implement energy into my Hopfield network so I can just like see what's going on in my code. Okay. And then I also had Claude Code advise me on how to make sure that because I actually for what I learned how to calculate theoretical capacity, the thing that I was like, how on earth is my supervisor doing this? And yeah, and mine was actually beyond capacity already. So I basically had it rewrite the pattern thing so that it was a more respectable pattern. So it rewrote my thing so that the stored patterns are it has 3 patterns and yeah, so it has 3 pattern. Oh, okay, now I understand why okay, it doesn't matter. It has 3 patterns and they're a little bit different and then it also has a noise function that is adding the noise. So it's just more now it's within the theoretical capacity. And so it still has 20 it has 25 neurons, but spread out between 3 patterns versus before it had like 5 neurons, 4 patterns. That was a fix, that was a change. And then I ran everything again. I also, yeah, I think that was really it. Those were the 2 things I added. So I added energy, I added those things. All of this got deleted / I just didn't care enough to put it in because I wasn't being entertaining or interesting. I was just fixing code. So you can see it looks very different now. And this was what's really interesting. I'll try to recreate the moment. Like I'll try to act it out for you. Okay, now I fixed the code. So I'm gonna see like what happened, like what's going on down here. Oh my gosh, the energy actually changed now. So it's not just printing out 0 for energy. That's so interesting. There's like ones in here now. What the heck? Let me try to see, like, what if I change the acetylcholine to 0.3? Like, will that change the energy? Okay, guys, let's see what happens. Oh my gosh, the energy's completely different. What the heck? Wait, can I make a result out of this? Wait, this is crazy. I'm like actually getting results now. What the heck? And so now we're gonna have capacity and we're gonna have energy. Wait, let me try like all the different numbers now. Let's put all the numbers in and see like the energy for each time, and then I go beep beep boop boop boop. I put the code in. Okay, you get the gist. And then I was like, oh my gosh, it's like changing so many numbers. Like it's actually going up, guys. I actually think I'm gonna have like another graph. I was like, wait, is the energy like that's not the same thing as what my supervisor was saying, right? And then I looked ChatGPT. Let me make sure. I don't think that it is. Beep 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 beep. Okay, it's not. It's really different. I hate ChatGPT because it's so annoying. And okay, then we come back and we get all the numbers 0, 0.3, 0.5, 0.7. Wait a minute. And then I noticed something. I was like, wait, this is crazy. Look at the numbers. Like it jumps from 0 from 0.7 to 0.8. It jumped so sharply. Like it was going like beep 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 beep, and then it was like going kind of like up, and then there was like this sharp jump like this. I was like, that's crazy. And before I didn't have 0.8, and I was like, okay, what the heck? Like, why is it going from -17 to -1? Like, that's kind of weird, right? Let me check the output. And then I checked the output, and yeah, basically I checked the output, and the output, what was interesting is that up until that point, it was basically able to recall the memories. So like it was actually recovering this. It was still able to like remember the original pattern, but once it hit that point, it that's the point. I was like, wait, it seems like there's a point that it's like now it can't recover, like it can't recall the memory anymore. And so it like there was like a bump, and I talked through all the different things I was thinking about that. I said like this is so lame that I have to say all this all over again, but it's important, so I'll say it. I was like, that's really interesting that at some point, I was like, first of all, I was a bit worried about my results because even at like 0.5, there wasn't a point where it was just like a little bit different. Like there was like that sharp cutoff from like, okay, this is working to this is suddenly not working at all. And I was like, I need to think about that. Like, what does that mean for my thing? I thought there was going to be a point in the middle where it's like it's getting like a halfway, like it's kind of remembering, and then but then I was saying like maybe biologically that would be equivalent to somebody like, oh, I'm conversing with you and I still can remember. I just can't it just takes a lot of effort for me to remember if acetylcholine is up, but then once it hits a certain point, it's like, okay, I truly can't remember anything. Like I can't, like there's nothing here. I just thought that was a bit strange because of other things that I read. So I was like, is that a thing with my numbers or what? And then I was like, okay, so I just thought that was a really interesting jump. And I want to explore that a little bit more about like, why is that jump there? How does that jump happen? And like, what can that teach me as well? And it made me think that maybe my acetylcholine function is working because I just thought it was pretty interesting how it's like as it's going up, the amount of energy that it's expending at each time is going, I think, down, right? Wait, I need to figure out. Let me actually double check that myself because it's giving the energy at like the first. I only took the energy at the first iteration at each number, and there were still some differences, but I just don't know how to read energy 100%. So I'm just gonna ask. Okay, so I guess that's just showing that my acetylcholine is actually working. So I'm still trying to learn energy, but I guess I'm gonna talk about show that probably as a graph still, like the energy is being function is being scaled down. What does that mean? So lower energy is a more stable attractor. So it is working that you can, okay, so actually what that confirmed for me, which is the only important thing that now I need to know, It's just that it does seem like whatever I was doing with acetylcholine is working, I think, because there's the more acetylcholine, the weaker the attractor. But what's interesting about that in a Hopfield network setting is that even though the attractor was getting like weaker, I guess there's a certain point that it hit where it was like it just really flatlined versus like, yeah, it's pretty interesting how it was still working fine up until about this point. Stored memories become less stable attractors. So I think all that I learned from that essentially is that this what I did worked. I think I'm pretty sure that means that I can just keep it like this and I don't have to change it or do something different. Reduces the influence of stored memories. Yeah. So anyways, that's what I learned. So that really shortened it. That took me forever and everything, but I guess I'm gonna talk about energy, about how I guess that's just showing me my how my acetylcholine function is working and that I guess it does work as you go up. And that it's really interesting that this happens here. And so what's interesting is that you've like also at this point at like 0.3, it's really low. There's still two iterations, I guess, at each part, it seems like. And then I don't know, like there's I think there's just little things to discover about how my network is working. So you get two iterations the whole like a lot of the way through. And then once you get to 0.8, the cutoff point, let's see. Then it really flatlines and it's stuck there. So you see at about 0.8, it's just not feeling it anymore. So I'm gonna have to think about that. Yeah, that's essentially it. That's everything that I learned and everything that I did for this section. And I guess it's kind of cool that I'll get to include that energy. I don't know. I don't know. I guess that's probably important to include, but yeah, I'm starting to get numbers, which is really fun.